Okay, this is lecture 2. In lecture 2, you will be able to know how to add, subtract, multiply, and divide the matrices. If you have two matrices, how you will add it, subtract it, and multiply it. Also, you will be able to find the transpose of a matrix, and it is determinant. Okay? For here you have arithmetic operation in a matrices. If you have addition and subtraction, in addition and subtraction the size of the matrix should be equal, يعني it should be have the same size. If it has the same size, that's mean you can add it, otherwise no. For example here, if you see M and A, the size of this matrix, it is 3 by 2, and the size of this matrix is 2 by 3. 2 by 3 and 3 by 2 is not equal, so it is undefined, يعني that means you cannot add them because it has the different size. But N and M, N it has 2 times 3, and N also it has 2 times 3, that means it has the same size. If it is have the same size, you can add and subtract them. First, you will take the first element in N and also the first element in M. First element in the first row, first column, and first element in the first row and first column. Okay, then you will add it. 1 plus 0 is equal to 1, like that. 5 plus 1, 4 plus 2, minus 1 plus 4, 3 plus 0, 8 plus 2. You will get this matrix, N plus N. For subtraction, also it will be the same. 1 minus 0, 5 minus 1, 4 minus 2, minus 1 minus 1 minus 4, 3 minus 0, and 8 minus 2. You will get this matrix. That's mean in addition and subtraction it should be have the same size. If you want to add or subtract, the matrices should have the same size. Okay, now here for scalar multiplication, that's mean you multiply a matrix by scalar. For example, here you want to multiply matrix A by 5. You will say 5 times 4, 5 times minus 1, 5 times 7, 5 times 3, 5 times 0, 5 times 8. That's mean you will distribute. You will distribute 5 into matrices. You can't be careful, that's matrix, it has the square bracket. Okay, now here for the transpose. The transpose, it is the interchange between row and columns. That's mean every row will be the column and the column will be row. For example here, minus 1, 2, 1, it became row. It is a column, became a row. Minus 1, minus 1, 2, 2, 1, 1, 2, 2, 3, 3, 3, and 3, and so on. That's mean to find the transpose of the matrix, you will interchange between the row and the column. There will be, you have to interchange row and the column. Okay, now you have here a practice. Multiplying the matrix. If you want to multiply the matrix, also you have to know about the size. If the matrix A have the number of row, or sorry, number of column is equal to number of a row in a matrix B, that's mean you can multiply them. Otherwise no. Like for example here, the column of matrix A is 1 and the row of matrix B is 4, which is not equal. That's mean you will not multiply it. You cannot multiply it. Just you have to see the inner. Inner, that's mean the inside. If it is equal, you can multiply. If it is not equal, you cannot multiply. Here, the column of B is equal to 2 and the column and the row of A is equal to 2. That means the matrix, the size of the matrix, the answer it will be, or the result it will be 4 by 1. Okay, you see here 3 1 3 0, 3 and 0. If you want to multiply it, first you have to check the size of the matrix. This is 2 by 2, okay, and this is 2 by 3, and the column in matrix A you have two columns, and in matrix B you have how many row? You have two rows, so you can multiply it. How you multiply it? You will take the first row multiplied by the first column of the second matrix, and so on. First row by second column, first row by third column, and between them is addition. 3 multiplied by 1 plus 0 multiplied by 8. For the second one, 3 multiplied by 0, 0 multiplied by 2 plus. Okay, 3 multiplied by 3 plus 0 multiplied by 7. Then you will take the second one, 1 multiplied by 1, 1 multiplied by minus 1 multiplied by 8, and between them plus 1 times 0 plus minus 1 times 2, and 1 times 3 plus minus 1 times 7. Okay, this is how to multiply the matrix. This is the way of multiplying the matrix. But if you want, for example, to multiply B times A, just to check that it will be equal or not. Okay, this is the practice of the matrix. And here also, if you want to find the determinant, it has the absolute of A. It is denoted by a line like this, or absolute. Okay, if you want to find the determinant, guess by cross multiplication, and between them is negative, minus A times D minus B times C. Guess multiply. And the determinant, it is a scalar. That means you will get the number, and this number maybe it will be positive, negative, and 0. It can be 0, positive, negative. Okay, that means it's okay for finding the determinant. Now, if the determinant is equal to 0, we call the singular matrix. When the determinant equal to the 0, we call the singular matrix. That means the singular matrix, that if the determinant is called the singular matrix, if it is determinant is equal to 0. The matrix we call the singular matrix if it is determinant equal to 0. Okay, here if you have a 3 by 3 matrix, when you will have a 3 by 3 matrix, to find the determinant, you will be change it or convert it into 2 by 2. That's mean you will take first element, first you have to find the what's called the Pascal. Okay, that's mean you will change the sign of the first row by putting the first one positive, negative, positive, positive, negative, positive. Then you will take the first row and delete any element with that row. Like for example, A, B, C, you will delete it, and also A, D, G, you will delete it. You will get E, H, F, J. Okay, now here you have minus B. Delete every element which is on the row and the column of B. Okay, you will get here D, J, F, I. And also for the third column, delete it, you will get D, E, J, H. After that, you will find the determinant of the second of 2 by 2 or square matrix. To find the determinant, the matrix should be square. If it is not square, you cannot find the determinant. Okay, here an example of finding the determinant of 2 by 2 matrix, and here he told for you to use the second row. Okay, how to use the second row? First, you have here positive by Pascal. It is positive, negative, positive, and so on. Here it is positive, so this will be negative, positive, negative. And will be the example and exercise for the determinant. And also this question, it is to find the value of x, how we will find the value of x. Okay, if it is a singular matrix, so that's mean the determinant is equal to 0. So how you will find the value of x if the determinant is equal to 0?